Hi, welcome to Pathways to Chemistry. This is Dr. O'Connor. Here we're asked, what are the equilibrium concentrations of all species, that'd be the nitrogen, oxygen, and nitrogen monoxide, if zero point 0.2 moles of nitrogen is mixed with 0.2 moles of oxygen in a 1 liter container. Here we're given the equilibrium constant at 2000 degrees Celsius. So the first thing we need to do is determine the concentration of nitrogen and oxygen, the initial concentrations, that is. So what we have here is 0.2 moles of each in a 1 liter container, so that would just be 0.2 molar. Okay, so we have that. So let's go ahead and set up our equilibrium concentration table. So initial change and equilibrium concentrations. So here we start off with 0.2 molar nitrogen and 0.2 molar oxygen. And of course, initially there would be 0 nitrogen monoxide. And so again, the concentrations of nitrogen and oxygen are going to decrease as the reaction proceeds. And they will decrease by some concentration X. And of course, the nitrogen monoxide concentration will increase by some amount 2x. Here we have the coefficient 2, so by some amount 2x. And then finally at equilibrium, we are going to have 0.2 minus x, and again the same for the oxygen, and of course the nitrogen will just be 2x. So now we can write our equilibrium constant expression. So Kc is, we have the nitrogen monoxide concentration. Don't forget the exponent. Remember, coefficients become exponents. And concentration of nitrogen and oxygen. And of course, that's going to be equal to 4.1 times 10 to the negative 4. So let me go ahead and put that in for Kc. So 4.1 times 10 to the negative 4, that's Kc. Let's start putting the concentrations in, the equilibrium concentrations. So here we have 2x for nitrogen monoxide. Do not forget the exponent. And then in the denominator we have 0.2 molar minus x, and then 0.2 molar minus x for the oxygen. Now, let's go ahead and clean this up a little bit. So I'll keep this the same. So we have 2x to the second power. And I can combine these, and that's going to give us 0.2 minus x squared. Okay? And again, that's equal to our equilibrium constant of 4.1 times 10 to the negative 4. Now, I noticed something here. I have a perfect square. This is going to make the calculation very easy, because if I have a perfect square, then I can take the square root of this expression and of course take the square root of the equilibrium constant. And this is nice because this simplifies this expression to 2x over 0.2 minus x is equal to the square root of 4.1 times 10 to the negative 4, which is 2.02. I'm going to retain some extra digits here to eliminate the rounding error, times 10 to the negative 2. So all we need to do now is solve this for x. So x is equal to 2.0 times 10 to the negative 3 molar. Okay, so now we can determine our equilibrium concentrations. At equilibrium, the concentration of nitrogen and the concentrations of oxygen are equal, and they're equal to 0.2 minus x, which would be 0.2 minus 2.0 times 10 to the negative 3. And they're just equal to 0.2 molar. And then the concentration of nitrogen monoxide at equilibrium is just equal to X is equal to 2X, which is 2 times 2.0 times 10 to the negative 3 molar. And that is 4 times 10 to the negative 3 molar. So here we were able to simplify our calculation nicely by recognizing that we had a perfect square.